Now we're going to talk about precipitation. We're going to talk about the intensity, duration, and the design storm event. When we start talking about precipitation, we have to figure out how we're going to actually measure it. So there's some typical gauges that they use. The universal weighing gauge, the tipping bucket, and the floating type gauge. Now here is the universal weight gauge, and and in here, when the water comes through, it starts to draw on this graph. You take this paper and you translate it into actual rainfall depth. So rainfall is measured in inches or millimeters, and it's referred to as volumes, even though it's measured in depth. And the reason why it's measured in volume is because this is typically, you think of it as a watershed. Anybody that draws a symbol like this is talking about a watershed, especially with a little blue line with 3 dots. That means it's a stream. So anyway, it's measured in inches because we're always thinking inches over an entire area. So to us, volume is in inches, even though we're talking about inches times acres, acre inches. Now, when we're talking about precipitation, we're taking a look at it in, go ahead and read through this, but we're taking a look at it in intensity, inches per hour, millimeters per hour based on time. So let's say we have a rainfall event and it has this intensity. From 0 to 1, it has almost 30 millimeters per hour. 1 to 2 hours, it has a little bit more. 2 to 3 hours has the exact same, but 3 to 4, it jacks up to almost 35 millimeters per hour and then goes back. So if we drew a bell curve or some type of curve over the top of it, we would have an intensity rainfall curve. If not, then we're talking about, this is more like a HYETOGRAPh. Here's another storm event, different times of year. So this one was January and this one was in July for the Kickapoo Station. So we always use this to start with to determine the rainfall, how much precipitation is actually coming down that we have to figure out for our design storm event. So when we're talking about the HYETOGRAPh, we're talking about a chart showing the rainfall distribution as a function of time. So depth versus time. This is a change in time. When we go to intensity, we're going to take the depth divided by this change in time. It's going to have the similar pattern, but we're looking at it in a little bit of a different way. One is in depth and one is going to be in inches per hour. Okay. Note that rainfall is not constant with time. Rainfall patterns vary with locations, but we assume that to make our lives a little bit easier, depending on what we're doing, it can be constant for a short amount of time. Now, where do we get the data? We have 2 sources. We've got the Engineering Field Book manual over here, Chapter 2, and it gives us the 2-year, 24-hour storm events, 2-year, 5-year, 10-year, 25-year, 50-year, and 100-year. Okay. Now, most of the time we use the TR55, the Technical Release number 55 manual, which has in the appendix the 24-hour storm for the 2-year, the 5-year, the 10-year, the 24-hour. We also can get it from the FDOT books, their manuals, because some counties require you to do a 10-year, 72-hour storm. Other counties make you do a 25-year, 24-hour. Remember what that means, what the frequency means. How, statistically speaking, does it occur if you took a, in 100 years, in a 2-year period, this occurs how many times? Okay, so when we're looking at this, I'm always going to go back to the TR55 because that's the most often that we use. So the distributions, so in certain areas of the states, it'll actually have, like, if you're looking at this graph here, a slow rainfall coming in, and then it starts to rain really hard, and then it starts to slow back off. So in this, we have a fraction of a 24-hour event. And notice it goes from 0 to 1. That means that it's broken that 24-hour event down into one fraction of it. The other thing you really need to pay attention to is the 1, 2, 3, and the IA. We are actually in the type 2 storm events. So when we do our designs, we're always going to look at the type 2 event when we're designing. So the distribution included in the rainfall intensities for select storm frequencies or design frequencies. Okay, so this is really important when we start to look at it, that we're a type 2. Notice that we have a low at the first few hours up to 9 hours, 10 hours. It's, you know, we don't have a really big amount of intense rainfall, and then all of a sudden, boom, from 10 to 12 to 13, 14 hour, we get most of our rainfall occurs. Now, this is one of the graphs in the book for the time of concentration. We'll be using, you'll see this again, the P 2-year 24-hour. It's used in the time of concentration calculations. So these are called ISO lines. So we're looking at us here in Florida. So I blew up a picture. If we're looking at Osceola County, here is 5.5, here is a 5, a 4.5. So we're looking at maybe a 5.5 event. So as in inches per hour, I'm sorry, is in inches of rain for a 2-year 24-hour. We'll have these for the 10-year, the 50-year, the 25-year, and the 100-year. Now, when we're talking about intensity, this is actually FDOT's intensity. So they are looking at it on when we're doing, we've got 2 equations that we'll be using, and I'll go over this a little bit later in this semester. We've got the TR55, which looks at the rainfall as in the inches of runoff, whereas we look at the rationale method, which looks at CFS, the peak discharge in CFS, not as in inches of runoff. So when we're looking at this, we're looking at rainfall intensities. Notice here over on this side, we have the 2, the 3, the 5, the 10-year, 25-year. So our duration is typically thought of as our time of concentration. You know, so we have a 60-minute time of concentration, and we go up here and we find it's a 10-year storm, and then we come over here and find out what the I factor is, the intensity factor. These are called intensity duration curves. Now, again, we'll be using this for figuring out peak flow for our storm pipe systems. The other thing is we're in Zone 7 in Osceola County. There's going to be different zones all over the state of Florida. I thought, there we go, I had the map here. So here we are in Osceola County, Polk County, Orange County. These are all typically in Zone 7. Polk County might be in Zone 6. I can't see the dark line over here. So we have all these different intensity duration curves that we're going to use the I value, how many inches per hour comes down, to figure out peak discharge to design pipes. When we design ponds, we actually use peak runoff in inches. All right, so there's that curve again. Sorry, I got it out of order. All right, so I'm going to go ahead and stop here. So that was what our precipitation, just as review. When we're talking about precipitation, what we're really interested in is the HYETOGRAPH to convert into a intensity duration curve, or we can just go ahead and use intensity duration curves that are already created for us, whether it be this one or this rainfall. This is in inches, whereas this rainfall is intensity is actually in inches per hour. But when we start to do the equations, I'll start to explain those a little bit more. So I'm going to go ahead and pause here, and then we'll go on to our next topic.